Hello, dear friends, students, learners, and viewers. Today we have to again take up a topic relating to significant figures. We know that more the number of significant figures, higher will be the precision. Lesser the number of significant digits in a number, lower will be the precision. But we need to limit the number of significant figures for our own convenience and proper representation of a number amounting to maximum precision. Therefore, this is done by rounding the number containing significant figures. How do we round it? There are certain set rules. We have to follow the rules, applying our own concepts, and at the same time practice is very important. The more you practice, the more confidence you gain. Of course, practice brings perfection. So we shall go through the rules and practice it simultaneously through certain examples. Please preserve whatever is being taken up here. Thank you. We start. So it is here how to round up significant figures, and we shall take up calculations involving significant figures and how to report it. But before that, we have to go through the rules which I have provided here with limited uh, points which are necessary for us. A few rules are here for rounding the significant figures. Now, what are those rules? We have to go through it. Now, we have to view the number provided, and we have to first fix up the determine the number of significant figures we need so as to get maximum precision with limited number of significant digits. So, here is an example. Suppose the number is 4.416. The number of significant figures here are 4. And we want to limit it to 3 significant figures. How this is done? The first rule is look at the rightmost, at the right hand, rightmost number. If it is more than 5, then you have to remove that number, thereby increasing the preceding digit by 1. So 4.416 would become 4.42. Of course, the example here is a different example, 1.386. It becomes 1.39, the same way. Now, if it is the number is less than 5, 5 is important, rightmost digit. If the number is less than 5, then the preceding limit is not changed. For example, it is 4.4334. 4 digits are there, and we have to limit it to 3 digits. How this will be done? Without changing the preceding digit and removing the last digit. So 4.334 would become 4.33. Here, 4.334 gets converted to 4.333, 4 digits being converted to 3 digits. Similarly, there is the governing number, I can say in each case 5, 5, more than 5, less than 5. We have taken two cases. And suppose it is just 5, then what will happen? If it is just 5, the last digit is just 5, and the preceding number is an even number. Odd and even is known to us. If the preceding number is 5, then what will happen? The number will not change. 8.25 will remain as 8.25. Of course, again there is a question. We want to reduce or decrease the significant figures, but in this case we find that it is not being decreased as per rules. So we have to use and apply our own requirements. If you feel that 8.25, by decreasing the digit, limiting to two significant figures at 8.2, will not affect the precision very much, then we can say, we can reduce it and we say it is 8.2, or sometimes you can make it 8.3. But well, this is the discretion of the scientist or the mathematician or its requirement in this case. Otherwise, three digits will remain three digits significant number, and the preceding number, if it is just 5, and if the preceding number is an even number, no change. But if the preceding number is an odd number, then what will happen? Then this 5 will be removed. Say 6.35 is there. We remove 5 and convert the preceding number, change the preceding number to 4, increase by 1. So that is how we follow the rules, and following these rules, we proceed further to take up several other examples. Of course, a few examples we have been discussed here. You may go through it. And then specified number of significant figures. This is very important. First thing is you are required to determine the number of significant figures we need to maintain precision that serves our purpose. We cannot have so many significant figures, although the precision is higher. We have to limit it. So that's there with certain example. For example, 2.3456 has 5 significant figures. We can convert it to 2.34, 3 significant figures. Fewer significant figures, lower precision. And again, here there is a practice about rounding up of the number. The same rules are being followed. You may go through it. 4.416 become 4.42, and 8.25 remains 8.25. But you have to apply your own discretion. If you want two significant figures and your purpose will be served by two significant figures, you can say it is 8.2, or sometimes you can take it as 8.3. Of course, 6.35 will become 6.4. Here is another example, rounding to two significant figures. Here we have to follow a procedure for rounding a number having 1, 2, 3, 4, 5 significant figures, and it has to be rounded to two significant figures. What we do, we just pick up the last digit in a number and then move to the preceding digit, change the preceding digit to the next number, and we proceed this way. Say example 3, 4, 5, 6, 7. We consider this 7. 7 is more than 6, so it will become 3.457. Now this 3.457, 7 is more than 5, it becomes 3.46. Again we find that 6 is more than 4. Therefore, we convert it to 3.5. That is, rounding occurs through stepwise processes, starting from the last number on the right hand side and moving to the left number till the desired significant digits are arrived at or reached. Now here there is another case with 0.000786. Now we know that zeros are just placeholders. They are not the significant figures. They are not considered the significant figures. So how many significant figures are there? 4 significant figures. Follow the same procedure. 6 to 5, 5 is converted to 6, and then 5 to 8, 8 is converted to 9. So the number becomes 0.00079. Or you can say, in scientific notation, it is equal to 7.9 into 10 to the power minus 4. Now, rounding to 3 significant figures. The same procedure is followed here. You go through it, try to understand, and the same procedure gives it here that 0.02784 is converted to 0.028. Of course, I have taken 0.278, not 84, because 4 is not going to affect 8. 4 is lesser than 5. So it will remain as such. Similarly, 4 significant figures. Here there is a very big number having so many significant figures. 1, 2, 3, 4, 5, 6, 7, 8. 8 significant figures are there, and we want to convert it to 4 significant figures. Follow the same procedure, picking up the last right side, last number or digit, and move to the preceding digits this way, and finally you get 1, 2, 3, 5 here. Next, we have to perform very often, rather frequently, certain calculations and limit our results to the desired significant figures. So, here is a very simple example. It may be addition, it may be subtraction, it may be multiplication or even division. In all these cases, we have to limit our results or the answers to the desired significant number or significant digits. Suppose we are required to add 4.23 with 1.93. We take care that the decimals of each number follow just below it. 4.23 is written as 1.9 decimal in line, and simple addition is there. You get 6.13. Now, the answer or the result which you get should be limited to the number of significant figures of a number which has least number of significant figures. For example, as you see here, there are 3 significant figures in 4.23. 1.9 has got 2 significant figures. So our answer should be limited, or our report should be limited to 2 significant figures, and it will be 6.9, 6.1. Sorry. Similarly, there are other additions also. You may go through it and you will find the same procedure being followed. Same for subtraction also. Limit the number of significant figures by the lowest number which has got minimum number of significant figures. So that's there. And here it is 89.65. The same thing happens here. Why it cannot be 89.6 or 89.7? I've already explained this is reporter's discretion. If he feels that the three significant figures will serve the purpose, he can take up as 89.6 or 89.7. So that's there. But as per rules, it is not to be changed and it has to be 89.65 because there is an even number, preceding number is an even number. Now let us go through multiplication and division. Same rules are followed here again. Number of significant figures as the number with the fewest significant number. Now 12.04 multiplied by 3.5, we find that 3.5 has two significant figures. So we have to limit our answer to two significant figures, although the answer is 42.14 here as per calculation. But so far as precision is concerned, we need 42. Now let us see. There are certain other examples. Please, I advise you to go through it. The results are here and all these steps are being mentioned here for your convenience. Now, let us see a case of calculation relating to division. Divide 8.6 by 2.17. Same thing again here, same consideration. Now, in this particular case, we find both the numbers have three significant figures, round the results into three significant figures. And that way, if it is done, we find it is 3.98. Same is the case here. It is 0.014. So please go through it. And again, I repeat that more you practice, the more confidence would be there. Different type of questions, different type of rounding up of the numbers using significant figures leading us to precision is very important. So I have given you all the examples here, and using these examples you can carry out simplification also. Suppose there is a big expression and you have to simplify it, because we know that simplification is nothing but a jugglery of plus, minus, into, and division. So following those rules and taking care of the precision and our requirements or the number of digits, you have to carry out calculations and report the result. Okay, thank you. We stop here and we shall be back again with some other topic a little later. Thank you.